Hi, in previous lecture I discussed how to convert finite automata to regular expression by using Arden's lemma and state elimination method. Now I'll discuss how to convert regular expression to finite automata. There are two methods. One is method of synthesis, another is method of decomposition, or it's called as state creation method. When we are converting finite automata to regular expression, it was state elimination method. Here is state creation method. So first I will explain method of synthesis. Regular expression is phi. Phi means empty language. For that we just need one state. If there is no final state, then it will accept phi. Regular expression epsilon. If initial state is the final state, then it will accept epsilon. Next, regular expression is R. For that we need two state and you can simply write R. So this is for regular expression R. For concatenation, if regular expression is R1, concatenation R2. For R1, create one finite automata. For R2, create another finite automata. Now R1 and R2 is done. Now we will concat this. So how we will concat? Just add a epsilon transaction between both. This is R1, this is R2. We just add a epsilon transaction between both and this final change to non-final. So now this is the concatenation of R1, R2. You can simplify this without writing epsilon. You can write directly. This is R1, this is R2. Just to change this final to non-final. Next R1 plus R2, or you can say R1 union R2. If this is R1 and this is R2, then what we will do, we will create new initial state and from that you will add epsilon transaction to both R1 and R2. So this is a new initial state and we added epsilon transaction both R1 and R2. And there are two final states. So change R1 final state to non-final, then this final state to non-final and create another new final state and add epsilon transaction from both. Now this is R1 plus R2. This is using epsilon, or you can say this is epsilon NFA. You can simply make DFA. Rather than using epsilon, you can simply write R1, R2. Now R1, R2 are parallel edges. So you can simply write in one edges. This is R1, R2, or you can write R1 plus R2. So now we got R1 union R2. This is epsilon NFA, this is DFA, and this is the simplified version. These are two parallel edges. So you can write in one edges. Next R clean closure. What is clean closure? Clean closure means it will accept epsilon, then single R, then 2R, 3R in a number of R. This is the finite automata for R. So what you will do, add one new initial state and add new final state and make epsilon transaction. So just add epsilon transaction to this initial state and from this final state we add a epsilon transaction to the new final state. Now by this epsilon it will repeat. It will accept single R, then epsilon, then 2R, epsilon 3R, epsilon 4R like this. But R clean closure it also accept epsilon, but here it will accept minimum 1R. So what you will do, add epsilon transaction from initial state to final state. Now it will accept epsilon, then it will accept single R, then it will accept 2R, 3R like this. You can simplify also this rather than this epsilon and this epsilon. You can remove these two and you can simplify like this. This is R and this epsilon for repetition. Then you can add another epsilon for epsilon transaction. Now it will accept single epsilon, then it will accept R, then it will accept 2R, 3R like this. And you can also remove this epsilon. Rather than this epsilon transaction, you can change initial state to final state. If you are changing initial state to final state, it will accept epsilon. And you can add this epsilon for repetition. Here also you can change initial state to final state. If you are changing initial state to final state, you will not add this transaction. Either you add a epsilon transaction to final state or change initial state to final state. Next I will explain positive closure. What is positive closure? Positive closure means it will accept single R, then 2R, 3R like this. It will not accept epsilon. It's same as this without this epsilon transaction. Just add epsilon transaction to initial state and here this epsilon transaction for repetition and add another epsilon transaction to final state. You can simplify this. You can remove this epsilon and this epsilon just to make a simplified version like this. Now this is R positive closure. Single R, Then it will accept 2R, 3R like this. This is same as this, just it is not accepting epsilon. Here it is accepting epsilon, here it is not accepting epsilon. So that's why we are not using this transaction. We are not using this. In next lecture, I will explain state creation method. Thank you.